Okay, so some of you need a little bit of help with surds. I understand that. I had problems with it when I first started as well. So, okay, let's take this right from the word go. So if we have square root of 25, what we're looking for is what number multiplied by itself will give you 25. Well, that would be 5, because 5 times 5 gives you 25. If we have the root of 49, then again, what times itself will give you 49? Well, that will be 7, because 7 times 7 gives you 49. However, sometimes you might get a number, say the root of 5. Now, to find the root of 5, no whole number multiplied by itself will give you 5, so you would use a calculator to find that. But sometimes, excuse me, if we're doing a non-calculator paper, we would leave the answer in this form, okay? Because we wouldn't have a calculator at hand to give the answer. So we would leave this in this form, and this is what we call surd form. Okay? So that's really all surds are. Okay? Now, if we look at simple surd arithmetic, if I've got 3 root 2's and I add another 2 root 2's, then I've got 5 root 2's. It really is that simple. If I've got 7 root 2's, or 7 root 3's even, and I take away 4 root 3's, then I'm left with 3 root 3's. Really is that simple. Okay, because if I've got 7 dogs and I take away 4 dogs, I've now got 3 dogs. So that's really, really simple, okay? But what you do need to know is you need to know your square numbers, okay? So here, one of the questions from the assignment, root 8. So if we look at root 8, it's a bit like fractions or ratio, where we always cancel it down as far as we can go. So root 8, if I wrote down what times what will give me 8, okay? Now 2 times 4 will give me 8. So root 8 is the same as the root of 2 times 4. This seems to make sense to me. Now I know the square root of 4. I don't know the square root of 2, but I do know the square root of 4. Now the square root of 4 is 2. So I can take that out, but I'm left with root 2 inside. Okay, so root 8 is the same as 2 root 2, or 2 times root 2. Okay, so if we had root 18, now that would be the same as the root of something times something. Now what you're looking for is one of those somethings being a square number. Now 18, that would be 3 times 6, but I don't know the root of 3 and I don't know the root of 6, so they're no good to me. But I also know that 2 times 9 will give me 18. Now I know the root of 9 because it's a square number. So the root of 9 is 3, so you take the root out, not the number, and that leaves you root 2 inside. Okay, so if we looked at this one, root 12, so we have root 12. Now that will be the same as the root of something times something. So one of those somethings needs to be a square number. So like 2 times 6 will give me 12. Don't know the root of 2, don't know the root of 6. But I do know that the root of 3 times 4, because I'm looking for a square number, will give me 12. And I know the root of 4 is 2. So I have 2 and root 3 is left inside. Okay. Now if we look at root 32, so let's say we've got root 32. Okay, so again, same procedure, the root of something times something. Now, I could have 4 times 8, because 4 8 is 32, and I do know the root of 4. But I want to make it as simple as possible. Okay, because if I go 4 times 8, I'll be left with 2 root 8, and then I'm going to have to factorise again the root 8. So is there another way that I can get 32? Now 2 times 16 will give me 32. I know the root of 16 is 4, leaving me the root 2 inside. Okay, now I could have, let's say you took the root of 4 times 8, okay, so we say root 4 times 8, okay, quite rightly you would say the root of 4 is 2, leaving me root 8. But as we've seen here, root 8 can be broken down. So we're going to have 2 lots of, and root 8 would be 2 times 4. The root of 4 is 2, and 2 times this 2 would give me 4, leaving me the root 2 inside. So I would end up with the same answer, but it just takes me a little bit longer to get there. Okay, so this is a question of, do you know your square numbers? Okay, so something times something will give you this number. One of those somethings needs to be a square number. Okay, so I'm just going to pause the video for a second, and I'm going to move on to the next question. Okay, so now we get, write root 3 times root 6 in the form b root 2, where b is an integer. Okay, now don't be afraid by all of this language. An integer is just a number. Okay, So you're going to have something root 2, say 4 root 2 or 6 root 2. So b will be a number, but we know root 2 is going to be left. Okay? So if you multiply roots, the rule is this: root 3 times root 6 is exactly the same as the root of 3 times 6. Okay? This is always the case. And the root of 3 times 6 would be 3 sixes are 18. Now, we've got this far. Now we know our answer is going to have root 2 inside it. So when you get this sort of question, they're actually helping you get the answer, because you know that it's going to be 2 times something. Okay? So the root of 2 times something is going to give us 18. So it's just a question of what times 2 gives us 18. And we know the answer is 9, because 2 nines are 18. Now we know the root of 9 is 3, leaving us root 2 inside. So there we've given our answer now, 3 root 2, as in the form of b root 2, which is a number root 2. A number root 2. Job done. So if we look at b, so we have root 8 times root 18, then that's the same as the root of 8 times 18. So that will give us the root. Now 8 18s are 144. Now, I, being a nerd, happen to know the square root of 144 is 12, because 12 12s are 144. So that's my answer. My answer is 12. Okay? So there are some roots that are worth remembering that are greater than 10. So we've got 10 10s are 100. So that's the square number, 100. So if we've got 121, the square root of 121 is 11, because 11 11s are 121. The root of 144 is 12, because 12 12s are 124. And the square root of 169 is 13, because 13 times 13 gives you 169. Okay, so these three are worth remembering. Okay, so if you get big numbers like this, quite often you'll get, you know, they will be root numbers or square numbers, and you can find the roots very easily. Okay, so I'm going to stop the video there, and I'm going to do a sort of third part 2. Okay, so I hope that's helped you a little bit, and we'll move on to the next part in the next video. Okay, Surds part 2, this time it's personal. So simplify this surd expression. So we've got root 12 times root 8. Okay, so what I could do is I could go 12 times 8, which is 96, but that doesn't really help me a lot because 96 isn't a square number. Okay, so, and it makes it a little bit more difficult. So what I do know is that I can break these both down into surds because we've done this previously. So root 12, if you remember, okay, was the root of 3 times 4. Okay, and we know the root of 4 is 2, so we have 2 root 3 because the root 3 is left inside. And root 8 is the same as the root of 2 times 4. I know the root of 4 is 2, and I'm left with root 2 inside. So now what I've got is 2 root 3 times 2 root 2. Okay, so this is nice and easy. I know you don't believe me, but this is nice and easy. You multiply like with like. So 2 times 2 is 4. And then we've got root 3 times root 2, okay, which is the same as the root of 3 times 2. Okay, so that will give me 4 root, and 3 times 2 is 6. So that's my answer, 4 root 6. So let's do another one. Let's say we've got root 27 multiplied by, take one that we've done, root 32. Okay, now I could go root 27 times 32, okay, but I get a massive number, so it's easier to break these down. Okay, so root 27, something times a square number will give me 27. Now I know that 3 times 9 will give me 27, and 9 is a square number, which is what I'm looking for. So I know the root of 9 is 3, leaving me root 3 inside. So that gives me 3 root 3, okay, instead of root 27. And then root 32, if you saw the first video, we know that that's the same as the root of 2 times 16. I know the root of 16 is 4, leaving me root 2 inside. So instead of root 32, I've now got 4 root 2. So this becomes easier to handle because I've got smaller numbers. So again, you multiply like with like. So 3 times 4 is 12. And then I'm going to have the root of 3 times 2. So I get 12 root, and 3 times 2 is 6. Okay? So sometimes, especially if you've got bigger numbers, it helps to break them down into this surd notation, and then it's easier to calculate. Okay, so I'm just going to pause the video and I'm going to move on to the next question. Okay, so now we come on to this. Okay, now, and I understand it looks horrendous. Okay, if you've never seen this sort of higher maths before, it looks horrendous. Okay, but trust me, it's really easy. So the one thing that you need to understand is this. If I've got root, why did I write that? Okay, if I've got root 2 times root 2, my answer is 2. If you multiply a root by itself, you always get the number inside. Okay, the logic behind it is this. Let's say we've got the root of 4 times the root of 4. Okay, now I know the root of 4 is 2 times, and again I know the root of 4 is 2, and 2 times 2 is 4, so that is the same as that, so it must be the same answer. It must be 4. So if you multiply a root by itself, you get the number that's inside. Okay, so now we've got 4 plus root 2 and 6 minus root 2. Okay, so this is something that you've probably never come across before. Now when we get two brackets like this, what they are saying is everything inside this bracket must multiply everything inside this bracket. Okay, so this is where you have to be careful of signs. Okay, so if it helps, draw lines. Okay, so we're going to multiply everything here by 4 first. So 4 times 6 is 24. Okay, then we're going to have 4 lots of minus root 2. Okay, now the 4 is a plus and this is a minus, so a plus times a minus is a minus, and 4 lots of root 2 would just be 4 root 2. Okay, so that's everything multiplied by the 4. So now we multiply everything by the root 2. So root 2 times 6, which is the same as 6 times root 2, would just be plus 6 lots of root 2, because this 6 is a plus and the root 2 is a plus. Then we have minus root 2 times plus root 2. Now plus times a minus is a minus, and root 2 times root 2, remember, if you multiply a root by itself you get the number inside, so root 2 times root 2 is just 2. Okay, don't worry, I'll do another one so that you get the feel. So now we've got a number, some root 2s, some more root 2s, and then another number. Okay, so we deal with the numbers first. So 24 minus 2 would be 22. Okay, now we've got minus 4 root 2 plus 6 root 2. Okay, So think money. You're £4 overdrawn. You add £6 to your account. So what's the state of your account? Okay, so if you were £4 overdrawn and you put £6 in your account, you would now be plus £2. Okay, so minus 4 root 2 plus 6 root 2 will give you plus 2 root 2. And that's your answer. Okay, now I ignore this because this is going to happen anyway. Can you see you've got a number 22 plus c, which is another number 2, and we've got the root 2 that they said we would get. Okay, so let's try another one, and we'll keep minuses out of it. So let's say we've got 3 plus root 3 times 4 plus root 3. Okay, so everything is going to get multiplied by the 3. So 3 times 4 is 12. Now 3 times root 3, because they're all pluses, then this is going to be plus. So 3 lots of root 3 is 3 root 3. So now we're going to multiply by the root 3. So root 3 times 4 is just going to be 4 root 3. And then root 3 times root 3, remember, a root times itself gives you the number inside, so we get plus 3. So we've got a number, some roots, and another number. So we deal with the numbers first. So 12 plus 3 is 15. And then 3 root 3 plus 4 root 3. So if I've got £3 in my account and I add another 4 in my account, I'm now £7 up in my account. Okay, so we'll do one with a minus in. So let's say we've got 4 minus root 3 and 2 plus root 3. And this is something you're just going to have to get used to. I'm really sorry, I can't take it away. The plus and the minus thing will haunt you, even at degree level it will haunt you. Okay, so the more you do it, the easier it becomes. So first I'm going to multiply everything by the 4, and the 4 is a plus because there's no sign in front of it. So 4 times 2 I know is 8, and 4 times root 3 is 4 root 3. Okay, so that's everything multiplied by the 4. Now we're going to multiply by the minus root 3. So we've got a minus times a plus, so that's a minus, and then root 3 times 2 is 2 root 3s. And then we've got minus root 3 times plus root 3. So a minus times a plus is a minus, and root 3 times root 3 is just 3. So again, number, roots, number. So 8 minus 3 is is 5. Now I've got 4 root 3 take away 2 root 3s. So if I've got 4 root 3s and I take away 2 root 3s, I'm going to have 2 root 3s left over. Okay, and you'll see all these answers come in that form. Okay, you'll have a number and then you'll have another number multiplying the roots. Okay, but in this case it's root 3 and not root 2. Okay, so this is just practice. You'll do this in algebra as well, okay, when you do quadratics. So don't worry if you make mistakes. Everybody makes mistakes. Okay, so what I'm going to do now is I'm going to do a part 3. Gets exciting, isn't it? And we're going to look at rationalising a denominator. Okay. Okay, the final part, hopefully the final part. So rationalise the denominator and then simplify. Okay, so what we've got is a fraction, but we've got a root in. Okay, now on the fraction, top of the fraction is what we call the numerator. The bottom of the fraction is what we call the denominator. And what they mean by rationalise means make it a whole number. Okay, they don't want to see a root, they want to see a whole number. 3, 7, 9, 2, 6, 5. They don't care, but they want to see a whole number. Okay, so what we do is we get a little bit tricksy. We know, for example, if we take A, I know that if I multiply root 2 by root 2, I get 2. I get a whole number. But I can't just multiply the bottom by root 2. Okay, because this would distort the fraction. So if we've got 10 over root 2, what I can do is this. If I multiply the bottom by root 2, which means then that I know I'm going to get 2. If I put this same root over the top, okay, so I get root 2 over root 2, that equals 1. Because anything over 1 is 1. So 1 over 1 is 1. 3 over 3 is 1. So anything over itself is 1. So if I multiply this fraction by 1, I'm not distorting it. Okay, that's the tricksy part. So whatever is the numerator, the denominator, you put it over itself. Always. So if this, for example, part B, excuse me, sorry, because I've got root 7 on the bottom, I would multiply that by root 7 over root 7, because that would make 1. So now, multiplying fractions is always my favourite because it's nice and easy. So 10 times root 2 would be 10 root 2. And root 2 times root 2, we know, is 2. So now I've got rid of that root on the bottom. But it says simplify, so it means that we can cancel this. Now I can't cancel the 2's, okay, because this is root 2. But what I can cancel is the 10 in the 2. So 2's into 2 goes once, and 2's into 10 goes 5. So we get 5 root 2. Okay, we don't write over 1 because anything over 1 is itself anyway. Okay, So if I do, say, the second one, so we've got 7 root 7, we've got to rationalise the denominator. Then what I do is I multiply that by root 7 over root 7, because that makes 1, so it's not distorting anything. And root 7 times root 7 is 7, and 7 times root 7 is 7 root 7. And I know I can't touch what's inside the root, but here the 7s both cancel. So I'm left with 1 root 7, or just root 7. Seriously, it is that simple, okay? So if I've got 15 over root 5, then I multiply it by root 5 over root 5. Root 5 times root 5 is 5. 15 times root 5 is 15 root 5. 5's cancel, leaving me 3 root 5. Job done. Okay, so let me put up another one. So let's say they try and make it hard. Okay, so let's say we've got root 18 over root 2. Okay, so what we do is we multiply by root 2 over root 2. So root 2 times root 2 is 2, and root 18 times root 2 is the same as root 18 times 2. Now, root of 18 times 2, 2 18s are 36, so we've got the root of 36 over 2. And it just so happens that we know the root of 36 is 6, and that's over 2. And 6 over 2 is 3. So our answer is 3. So we've not only rationalised the denominator, but we've actually made it an integer, a whole number. Okay, so I know these look horrible, and I know it's something that you're not used to, but with practice, I promise you it does come easier. Okay, the more you do it, the easier it becomes. Okay, so just keep at it. If you get stuck, you know where I am. You can always contact me and I'll go through it with you. Okay, but the things that you need to remember is any root times itself, you get the number inside the root. Okay, and you need to know your square numbers so that you can look for the square numbers in any number. So let's say we've got the root of 20. Okay, so can I break that down? So that's the root of, now what times what gives me 20? Well, 2 times 10, but neither of those are any good to me. but 4 times 5 is useful to me because it has that square number. Okay, and the root of 4 is 2, leaving me root 5 inside. Okay, I really do hope that these 3 videos have helped a little bit. As I say, any problems, come and talk to me. Okay, don't be afraid. I'm a very nice man. I know, because my mum told me. But you know, come along, and then I promise you, you'll see it's not as difficult as you believe. Okay, so thanks very much for taking time to watch the video, and just carry on doing what you're doing.